So welcome back from spring break. We're going to do lesson 12-2, which is all about tangents. And so hopefully by the end of this you can say that you can name the various theorems associated with the tangents of a circle. We're going to start off just kind of with some basic ideas of what a tangent line is. You've seen most of these things on this picture before, but a tangent to a circle is the line in the plane of the circle, so it has to be on the same plane, obviously. So we're thinking two dimensions here, that intersects a circle in exactly one point. That means that we have this line coming through here, and even though it looks like it basically hits it in two places, that's just the error of the drawing itself. But we're going to assume that basically as it gets closer and closer and closer, it hits it at one point, say like right here, right in the middle, and then it continues off and is then off the line. Okay. So our first theorem, so if a line is tangent to the circle, then we would say that it is perpendicular to the radius drawn to the point of contact. And so we take that one point that in which the line is actually drawn and hitting that circle, and we can connect the radius to the center of the circle N. We can draw that radius, and those two lines should be perpendicular to themselves, creating that 90-degree right angle. If a line is perpendicular to the radius of its outer edge, then we know that it is also tangent to it. That is just the flip of it, so the converse of our original theorem, but the same exact thing, and you're going to explore that process kind of the same exact way as the one before. Is that if I know that it actually is perpendicular, then I can say that it is tangent, whereas the other one said that if I know that it's tangent, then I know that it's perpendicular. So this one's just the converse of that. So our first kind of question that I would like to ask you is I'd like you to find the value of x. Basically knowing the fact that CB is tangent to my circle, and I have a center of my circle which is O. I know that the distance from O to C is 9. I know that the distance from O to B is kind of unknown. So I have a distance of but 6 here from B to the actual circle itself, and then x is the distance there. So I'd like you to pause this video, and I'd like you to try to see if you can figure out what x actually is based off of knowing that, so I want to know what this distance here. I know that CB is tangent, so I know that this creates a right angle, which then means I know that this is a right triangle. And so you're going to have to think to yourself, okay, so what relationships do I know about right triangles? What do I know from, here's your hint, from pre-algebra, that then allows me, that one theorem we learned in pre-algebra that then allows me to figure out the side lengths of a triangle. So if you could pause it right now, find out, and then I'm going to go through the answer here in just 1 second. So hopefully you're able to find out what x is, and so basically what you should be thinking is it's going to be the Pythagorean theorem, that you're going to figure out that 9 squared plus x squared is going to be equal to the hypotenuse squared. And so thinking about the hypotenuse, well, it's not 6, obviously, but it's also an extra distance here, and you may say, well, I don't know what that is. But if you think about it, it's also the radius of the circle. So if I know that the radius here is 9, I also then know that this is 9, so adding them together, it should be 15 squared. Using basic math after that, I would get 81 plus x squared is equal to 225. I would subtract 81 from both sides and then take the square root, so that I would get x is equal to 12. And you should have been able to do that. Next one I'd like to ask is basically, is CB actually tangent to this circle here? Is it tangent to the circle? So in the diagram at the left, we want to know if it is, based off of the information that's given to us, knowing that this is 3, knowing that this is 12, and noticing that this is 15. Now right away you might be thinking to yourself, knowing those values there, would it actually make a triangle itself? Thinking back to our triangle inequality, I know that the two sides of a triangle added together have to be greater than that third side. But let's just use the idea again as we figured out from before, using the Pythagorean theorem. Do I know if 3 squared plus 12 squared is actually equal to 15 squared? Again, using basic math, plugging in 9 plus 144, is that equal to 225? Well, obviously it's not, and so I would say that in this case right here, that I would say that CB is not tangent to the circle, because it does not create that right angle. if these two were equal to each other, then I know that that the Pythagorean theorem would work, which then means that this is indeed a right triangle. But because it doesn't, I know that it's not a right angle, and it does not follow the theorems that we learned prior to these examples. Last example that I want you to try on your own, or thinking to yourself, is again just a little bit of some practice here. Find the length of the radius of the circle. I'd like you to pause it, see if you can figure it out. You're probably saying to yourself that it's at a diagonal, and so how would I figure out what the diagonal actually is of this here, not being able to count the squares itself? Well, again, think to yourself, I have a length going horizontal and I have a length going vertical on all of my diagonal lines. So if I count the squares going over horizontally, I get to 3. I count the squares going up, I get to 4. So 3 squared plus 4 squared, that's equal to 9 plus 16, which is equal to 25. Take the square root of that. You should have gotten an answer of 5 units for your radius. So then the question is find the slope of diameter AB. Well, we could take basically do we need to figure out the entire diameter itself? Not really. So take just from the radius, because that's at a nice point here. How many squares am I going up? How many squares am I going over? We've already talked about that. That's 4/3. Find the slope of line L. So this is kind of where I'm going to let you again go off and try this on your own. So knowing what we just figured out with the slope of AB, if I know that L, I'm going to assume is what I know is L is tangent to this. Okay, I want you to try to be able to figure out is based on the fact that L is tangent, what is the slope of L? Think back to chapter 11 as you're going through this. So pause it for right now. So hopefully you're able to pause it, and I wanted you to think back to chapter 11 about the relationship between, okay, so if I do know that this actually is tangent, that means I create a perpendicular line here. So if the slope of the AB is 4/3, then I know that the perpendicular slope has to be the opposite reciprocal of that, which then means that it would be -3/4, or if you could think about it as just counting, looking for those lines there, I'm going down 3/4, which I basically have already given away the next question, which is what relation does line L have to AB? It would then be, of course, perpendicular to each other. And so this is where I'm going to leave you. So thanks for listening, and then come to class having kind of these examples listed down, so I'm able to take a look at those, and we'll do some more practice problems in class, and then we'll be able to get to the homework. So thanks everyone, and we'll see you next time.